Hello, Stat 200, and welcome to Lesson 3. This is the second of 2 lessons on describing data. This week, you're going to finish reading Chapter 2 in the Lock 5 textbook. These are the key topics that you're going to cover this week. We'll finish covering one quantitative variable in our discussion of box plots and outliers. Then, we'll move on to one categorical and one quantitative variable, 2 quantitative variables, and more than 2 variables. Let's begin by looking at one quantitative variable. Last week, you learned that for one quantitative variable, you could construct a dot plot or a histogram. In Lesson 3, you're going to learn about box plots. This is a single box plot. It displays data from one quantitative variable for one group. The box represents the middle 50% of observations. In other words, the interquartile range. The line in the middle of the box represents the median. The whiskers extend to the lowest and highest values that are not outliers. The asterisks represent outliers. By default, Minitab Express and most other statistical softwares use the interquartile range method of identifying outliers, which you'll learn about in the online notes this week. For one categorical and one quantitative variable, you can use many of the same graphs that you used with one quantitative variable, but now with multiple groups. For example, you can construct a dot plot with groups, a histogram with groups, or a side-by-side box plot. In the online notes this week, there are instructions for constructing each of these graphs using Minitab Express. For 2 quantitative variables, we could construct a scatterplot to display our data, and correlation and simple linear regression can be used to describe our data. Let's start by looking at a scatterplot. A scatterplot displays data from 2 quantitative variables. If you're working in a scenario where you have an explanatory and a response variable, the explanatory variable should go on the x, or the horizontal axis, and the response variable should go on the y, or the vertical axis. We can describe a scatterplot in terms of direction, form, strength, and outliers. In terms of direction and form, I would say that this scatterplot is displaying a positive linear relationship. The strength, just looking at the scatterplot, I would say is moderately strong, and there are no obvious outliers. If we wanted a more objective measurement of strength, we could compute the correlation coefficient. For 2 quantitative variables, the most common measure of correlation is Pearson's R. In a sample, this is signified as a lowercase r. In a population, it's signified by the Greek letter rho. In your online notes this week, you'll see this formula for Pearson's R. There is one example of computing this by hand in the online notes, just to show you how the z-scores relate back to Pearson's R. In this course, you'll never be asked to compute Pearson's R by hand. You'll always be able to use Minitab Express or StatKey. Let's talk about a few key points before moving on to simple linear regression. Pearson's R must be between -1 and +1. Relationships are stronger as they approach -1 and +1. If R equals 0, then there is no relationship. Correlations are unit-free. In other words, your x and your y variables do not need to be on the same scale. We can compute the correlation between height in inches and weight in grams. X and y are interchangeable. The correlation between x and y is equal to the correlation between y and x. Always make a scatter plot first to confirm a linear relationship. Pearson's R and simple linear regression are only meant to be used with linear relationships. Now, let's move on to talk about simple linear regression. You may remember y equals mx plus b from an algebra class. If not, there is a review of this in lesson 0. This week, you're going to see y hat equals a plus bx, where a is your y-intercept and b is your slope. Note the y-intercept is always the number that is standing by itself, and the slope is always the value that is attached to x. Here we have our scatter plot of height and weight with our regression line. Later in the course, we will spend a whole week working with correlation and regression. However, correlation and specifically the slope within regression will come up in the next few lessons as you're introduced to statistical inference. Now moving on to more than 2 variables. Between your online notes and your textbook, you're introduced to quite a few different graphical representations that can be used with more than 2 variables. Here we have a scatter plot with groups. So our x and y axes are height and weight. These are 2 quantitative variables. And then the different points are different colors and shapes, signifying the categorical variable of biological sex. So here we have 2 quantitative and 1 categorical variable. In this bubble plot, we have 3 quantitative variables. So height and weight are x and y variables that are both quantitative. And then the size of the dots, in this particular case, I believe responded to number of days per week spent exercising. So people who spent fewer days per week exercising have smaller bubbles, and those who spent more days per week exercising have larger bubbles. So in this case, we have 3 quantitative variables. In your textbook, you'll see a bubble plot that has 4 variables. 3 quantitative variables is here, and a categorical variable that is shown in different colored bubbles. The online notes and textbook also show you a time series plot. Here we have a time series plot for one student concerning their practice quiz scores over a series of 10 consecutive attempts. So for the practice quizzes, students are allowed to take it an unlimited number of times. Only their highest grade will count. So many students will continue to take the practice quiz until they get a perfect 15 out of 15. So this plot is showing how that student's score increased over time. On their first attempt, they started with a 7, and then by their 10th attempt, they had a perfect 15 out of 15. We could also construct a time series plot with groups. So here, the bottom line is the same plot that we saw on the last chart, but it added a second student. The second student only took 4 attempts, and we can see how that student's score increased over time as well. The last type of plot that we're going to look at here is a geographic plot. Here we have a map of the United States showing each county and who they tended to vote for in the Obama-Romney election. This is a world map showing life expectancy. These are just a few examples of the data visualizations that you can use with more than 2 variables. There are really many different possibilities out there. For your homework this week, I tried to select a few examples that I thought were easy to relate to and also showed you really what can be done with these current data visualization techniques given the current technology available. This concludes the Lesson 3 overview video. As always, if you have any questions as you're working through anything this week, post them to the Lesson 3 discussion board on Canvas.